Algebra 1, Lesson 33, Products of Prime Factors and Statements about Unequal Quantities. We're going to do this lesson backwards. We're going to go with, as far as the practice problems go. On the practice, we're going to start with C and D, and then we'll do A and B last. And C and D are products of prime factors, so we'll begin with those. So, starting with C, they tell us that we need to write the following numbers as products of prime factors. So this is what I like to call the factor tree, which means we have to rewrite 108, but write it using only prime numbers. So what we do is we take 108 and we split it. We ask ourselves what times what will equal 108. Well, if you remember your 12 times tables, 9 times 12 will equal 108. From there, we're going to factor the following numbers, because neither one of these numbers are prime yet. We'll factor 9, and that will turn into 3 times 3. These are both prime numbers, so those are good. If we factor 12, we get 3 and 4. Now 3 is a prime number, but 4 is not, so we factor 4. 2 times 2 will equal 4. So now we have all prime numbers on the bottom. Once all of your bottom numbers at the base of the tree are all prime numbers, we can simply write the answer as 2 times 2 times 3 times 3 times 3. And if we multiply all of these numbers together, we will get 108. So this is the same thing as writing 108, but we're writing it using only prime numbers, or prime factors, because they're being multiplied. And that's all you have to do. You just make a tree and you factor it down. It doesn't matter which numbers you use, you'll always get the same prime numbers if you do it correctly. For example, we could have factored 12 as 2 and 6 and still gotten the correct answer. Now let's go to D, problem D. We have to do the same thing, but we've got a bigger number. We're using the number 400. So I can factor 400 into 4 and 100, because 4 times 100 equals 400. 4 I can factor into 2 and 2. These are done. Those are both prime numbers. 100 I can factor into 2 and 50. 2 is a prime number, so I'm done with that. 50 we could do 2 and 25. And then 25 we could break into 5 and 5. Now that we've got all prime numbers at the bottom, we just write them out. 2 times 2 times 2 times 2 times 5 times 5. And that's our answer. Now, let's go on to A and B. A tells us to find a number such that 8 times the number is 36 greater than the opposite of the number. And then we have to check our answer. So again, we're going to be using the algebraic expression skills that we learned in lesson 30. And we have to turn this first half into an equation. Now the reason why they say that it is unequal quantities is because of this word right here, 36 greater than. So the idea is we have to find an equation where we can represent 36 greater than what they tell us next. So let's go to our work paper and we'll start working this out. The first thing they tell us is that we have to find a number such that 8 times a number is 36 greater than the opposite of the number. So we'll start by writing 8 times a number. We'll just put 8n. And the key phrase here is that 8 times a number is. Is like our equal sign. In this equation, is going to be where we put our equal sign. So we'll put 8n is. Now they say it is 36 greater than the opposite of the number. Now, instead of dealing with the phrase 36 greater than, we're just going to put the opposite of the number first. So the opposite of the number would be negative n. Now, this statement is not true because we have not applied the 36 greater than. This number is 36 bigger than this. So the way we fix that is we add 36 to this side, and now it is true. So now that we have our equation, we'll go ahead and solve. Add n to each side to get all the n's grouped together. 8n plus n gives us 9n. 9n equals 36. We divide by 9. And that's going to reduce to 4 over 1, or just 4. Now we have to check our answer 4. So we're going to rewrite this equation, inserting 4 for all the n's. So we'll put 8 times 4 equals negative 4 plus 36. So 8 times 4 gives us 32. Negative 4 plus 36 also gives us 32. This checks out, which means that our answer 4 is correct. Now I'll do B, but a little bit faster. So they want us to find the sum of a number, or they tell us if the sum of a number and 6 is multiplied by 2, the result is 10 greater than the number. So we have to start with the sum of the number and 6. So the sum is going to mean that we got two things being added, and what we're adding is the unknown number, or x, and we're adding 6. Now they tell us that sum is multiplied by 2, so we're going to have to take this addition problem, put it in parentheses, and then put 2 on the outside. When they say the result is, that's their way of saying the equal sign, and they say it's 10 greater than the number. So 10 greater than the number we could write as x plus 10. Again, we're putting that phrase 10 greater than at the very end. From here, we distribute our parentheses to get 2x plus 12. And then we want to group all of our numbers together. So we'll move x to the left and 12 to the right. We cancel, and then we add. 2x minus x just gives us x, and then 10 plus negative 12 gives us negative 2. So now that we've got x equals negative 2, let's check that answer. We'll rewrite the equation. 2 times negative 2 plus 6 equals negative 2 plus 10. We distribute, and that gives us negative 4 plus 12, and negative 10 plus, or negative 2 plus 10 gives us 8. So negative 4 plus negative 12 also equals 8, and that means that our answer is correct. So x is equal to negative 2.